Imagine the night sky unfolding before you. Not the familiar sky you see every evening, but a deeper, wider cosmic sky, stretching endlessly in every direction. The distant stars appear as soft, delicate specks of light scattered across an endless sheet of black silk. And in the quiet space between them, there is one glow that feels different. Not just a tiny point like the others, but a pale golden sphere, tender and calm, wrapped in a thin, shimmering ring. That is Saturn, the distant giant, drifting silently along its orbit around the Sun. From far away, Saturn is nothing more than a gentle glimmer in the night. But as your mind slowly glides closer, that blurred glow begins to take shape. Against the deep darkness of space, Saturn rises like a softly lit lantern, and its rings stretch outward like the brim of a wide hat woven from ice and cosmic dust. Each ring is more than a thin brushstroke. They are made of countless tiny ice particles, catching sunlight and scattering it into pale, delicate bands of light. The planet carries a beauty that feels almost otherworldly, both familiar and impossibly far away. Saturn sits sixth from the Sun, after Jupiter and before Uranus. It is the second largest planet in the solar system, just behind Jupiter, so immense it could hold more than 700 Earths within its volume. And yet, when seen from Earth with nothing but the naked eye, Saturn appears modest, just a slightly hazy golden star, bright but not harsh, quiet yet unmistakably different. You don't need a telescope to find it. Our ancestors recognized that gentle light long before modern science existed. In the stillness of this imagined space, the distance, over 1.4 billion kilometers from the Sun to Saturn, stops feeling like a cold statistic and becomes a slow, drifting journey of thought. Sunlight takes more than an hour to reach Saturn's cloud tops. That same light then reflects off the icy particles in its rings, travels onward through the dark, and eventually finds its way to a pair of small human eyes on a distant blue world. Every time someone looks up and notices that quiet, pale gold point in the sky, they are seeing light that has traveled a very long way, carrying Saturn's silent story with it. Let your imagination gently lift away from the ground, from the city, from familiar sounds, and drift upward. Earth's atmosphere thins, its blue fades, and the darkness of space spreads across your view. Earth grows small behind you, while ahead, Saturn slowly expands from a faint dot into a defined, glowing sphere. There is no sense of acceleration, no engine noise, just the soft feeling of floating, as though you're drifting through an invisible ocean. The closer you come, the more the details sharpen. The rings are no longer a simple line, but a vast system of many bands, stretching hundreds of thousands of kilometers across, yet astonishingly thin. From afar, the rings look like a transparent veil wrapped around the planet. But as your imagination draws nearer, you can almost picture each piece of ice, some tiny as grains of sand, others as large as buildings, circling Saturn in a slow, steady dance that has continued for billions of years. All of this unfolds in complete silence. No sound, only motion, the gentle sweep of cloud bands and the perfect curves of the rings. Saturn's pale yellow color, touched with cream and muted browns, makes it look like a sphere wrapped in soft mist. There are no vivid splashes of red, no violent storms on display, just quiet layers of clouds stacking gently, creating a view you could rest your eyes on for as long as you like a painting hanging in a tranquil room. Saturn is not only beautiful, it carries an ancient mystery. Long before telescopes existed, humans watched it, tracking its slow movement across the sky. For thousands of years, that golden point has appeared, faded, and returned again in long, steady cycles. While kingdoms rose and fell, while cities were built and abandoned, Saturn simply continued turning, keeping its own patient rhythm, like a distant cosmic clock measuring time with its orbit. Beneath the sky where your imagination has just drifted past Saturn and its gentle glowing rings, a soft question rises, like a small ripple spreading quietly through the mind. When did humans first notice that pale golden light above? As the giant planet becomes clearer in your thoughts, that floating sensation seems to guide you backward in time, toward the very first people who looked up at the night sky without knowing that what they saw would one day become one of the most captivating objects in astronomy. And just like that, the mind glides from the image of Saturn in the vast universe back toward Earth, where the story of observation truly begins. In Earth's night sky, Saturn appears as a faint golden dot, distinct enough to catch the eye but not dazzling like Venus, nor brilliant like Jupiter. It doesn't twinkle the way distant stars do, because its light is reflected sunlight, steady and unwavering. When viewed with the naked eye, the rings remain invisible, and its true shape cannot be distinguished. There is only that small golden glow drifting slowly from night to night, slow enough to notice that it doesn't stay fixed like the stars. That is why it has been known since ancient times. No telescopes, no instruments needed, only eyes and patience. To people long ago, Saturn was the farthest planet the human eye could see, and its remoteness gave it an air of quiet mystery, like a silent deity watching humanity from the edge of the sky. The earliest records of Saturn appear in the writings of ancient civilizations. The Babylonians tracked its path and marked its position on clay tablets more than 2,000 years before the Common Era. They noticed its motion was much slower than that of the other planets, and so they associated Saturn with heaviness and age. In ancient Greece, philosophers and early astronomers also observed the planet. They watched Saturn inch across the constellations, quiet and slow, like the long breath of time itself. Later, the Romans named the planet after Saturn, the god of harvest and time. Two concepts that move slowly, steadily, and anciently, perfectly matching the nature of the slowest moving planet, visible to the naked eye. For thousands of years, with no telescopes or any way to understand Saturn's true structure, civilizations relied entirely on its motion to form their theories. The Greeks believed it was the planet with the most distant orbit, and its slow journey was considered a sign of a distance so vast it defied imagination. Astrologers of the time used Saturn's path to predict major shifts in life, believing that the god of time could influence human rhythms. Yet beneath layers of symbolism and belief lay a simple scientific truth. They had observed it carefully for so long that they had recognized the pattern of a world more than 1 billion kilometers away. Thousands of years passed like this. Saturn remained nothing more than a dim golden dot, until one evening in 1610 when an Italian astronomer named Galileo Galilei pointed his eyes through a new invention: the telescope. This crude but revolutionary instrument changed humanity's view of the sky. When Galileo turned it towards Saturn, he expected to see a soft sphere, shaped by the telescope's low resolution. But what he saw was entirely different. The planet was not perfectly round. On each side were strange structures, like little ears or 2 small moons stuck to its edges. He sketched this odd shape and sent it across Europe. But even he did not understand what he had seen. With the limited optics of the time, Galileo had glimpsed only the outer blur of the rings, making them look like two mysterious masses attached to the planet. From that bewildering moment, a new chapter in astronomy began, though the true explanation was still hidden. Years after Galileo, the mystery was finally solved by the Dutch scientist Christian Huygens. In 1655, using a better telescope, he observed Saturn more clearly. This time, the planet's unusual shape became understandable. Huygens realized that the ears Galileo had drawn were actually a ring encircling the planet. The ring did not touch Saturn. It stood apart from it, a structure no one had imagined before. Huygens did not stop there. That same year, he discovered Titan, Saturn's largest moon, a world that would later become one of the most fascinating destinations in planetary science. Titan appeared as a quiet companion orbiting the giant world, carrying its own secrets within a thick, hazy atmosphere. Soon after Huygens, another figure expanded humanity's understanding of Saturn even further: Giovanni Cassini. In 1671 and the years that followed, Cassini discovered several more moons, such as Iapetus with its striking two-tone surface, and Rhea, Tethys, and Dione, icy spheres circling their planet. Then, in 1675, he found the Cassini division, the dark gap between Saturn's two major rings, A and B. That gap was more than just an aesthetic detail. It became a critical clue in understanding how the moons and ring particles interact through gravity. Looking back on this entire history, it becomes easy to imagine a gentle, unbroken timeline stretching across millennia. Humans watching a small point of light, relying only on their eyes, and gradually peeling back layer after layer of mystery through patience and curiosity. From a faint golden speck, Saturn became a world with rings, a world with many moons, a world whose secrets were slowly revealed by Galileo, Huygens, and Cassini. As the mind drifts quietly from the ancient world into the age of telescopes, Saturn is no longer just a lonely point of light. It becomes a world with a rich history of observation, full of stories that draw the mind downward and deeper, like a calm, steady current. And from the foundation of these early discoveries, the journey of exploration continues toward greater understanding of its orbit, its atmosphere, and its long, lingering seasons, where time moves with a rhythm far gentler and slower than it does on Earth. The flow of the story, beginning with humanity's very first observations of Saturn, spreads outward like calm ripples on water. As the image of that pale golden dot became the anchor for Babylonian records, and later came into clearer focus through the telescopes of Galileo, Huygens, and Cassini, another truth slowly emerged. Long before science ever reached the distant world, human imagination had already given it a name, wrapped it in mythology, and granted it a special place in cultural memory. Knowledge and legend blended softly, as if Saturn had always existed not only in the sky, but also in the human mind for thousands of years. The name Saturn carries an ancient story. In Roman mythology, Saturn was the god of agriculture and time. He was portrayed among wide fields, long cycles of planting and harvest, and the quiet passing of seasons. Saturn was not a youthful or fiery deity. He represented patience, slow rhythms, and steady cycles, much like the unhurried motion of the planet that bears his name. The Romans also believed Saturn was the father of Jupiter, whom the Greeks called Zeus. So within the naming of celestial bodies, Saturn appears before Jupiter, just as the father precedes the sun. This gives the name Saturn an old, layered cultural weight, a kind of sediment of history resting on a giant planet billions of kilometers away. In Vietnamese, the planet is called Sao Tho. The name is tied to the earth element in Eastern five-element philosophy, symbolizing stability, endurance, and the slow unfolding of time. By coincidence, but a harmonious one, both Eastern and Western traditions assigned the same qualities to this distant world: steadiness, a slow rhythm, quiet gravity, and long cycles. With meanings reflected through so many philosophies, Saturn becomes not just an astronomical object, but a cultural symbol. There is another detail tucked quietly into everyday life, one most people overlook. Saturday in English is named after Saturn. Every time the word is spoken, the planet is being invoked. Among the 7 days of the week, Saturday is the only one still carrying the pure name of a planet, revealing the powerful influence of ancient Roman culture on modern Western timekeeping. In traditional astrology, Saturn represents discipline, boundaries, maturity, and the lessons of time. When people speak of Saturn in an astrological sense, they often think of responsibility and the long stretches required for growth. In the context of this story, astrology is simply a parallel cultural thread, neither judged nor emphasized, just a reminder that for generations, people looked up at Saturn and shaped meanings that fit the way they understood the universe. Saturn's slow steps became a symbol of steady, inevitable order. In art, Saturn and the god who gave it its name appear throughout history. In classical European painting, Saturn was often depicted in symbolist works as an aged god with a harvest, scythe, transformed through the style of each era. These paintings reflect how humans understood time, destructive yet nourishing, creating seasons while also carrying away youth. When artists painted Saturn, they were not only illustrating a deity, but expressing humanity's emotional relationship with time itself. In literature, Saturn often stands as a symbol of distance, of rhythms quieter and more contemplative than those of the other planets. In many works of science fiction, Saturn and its rings become settings for reflective journeys. Writers see the rings as the perfect stage for describing beauty that is fragile yet vast, serene yet majestic. Some stories imagine research stations on Titan. Others depict shimmering ring light falling across frozen moons. In film music, compositions inspired by the planets, especially those titled Saturn, often carry a slow, spacious, wistful tone, mirroring the planet's own gentle drift through eternal darkness. In modern popular culture, Saturn continues to be a symbol of mystery. Posters of the planet hang on bedroom walls of astronomy lovers around the world. Space films often grant it a moment of reverence, a wide shot of misty rings, slightly tilted, floating in cold silence. A single image can evoke quiet awe, a reminder of how vast the universe is compared to everyday life on Earth. All these myths, cultural threads, and artistic echoes form a soft halo around Saturn. Not a physical mist like the planet's pale clouds, but a mist of memory, association, and the many ways humanity has tried to understand and interpret the cosmos. Even as science continues peeling back Saturn's mysteries, the planet retains an ancient stillness in human imagination. Slow, calm, steady, and deeply poetic. As the mind drifts from the telescopes of Galileo and Huygens into the cultural layers surrounding Saturn, it becomes clear that intellect and imagination have always walked side by side. One seeks the true structure of the rings. The other weaves stories to express their beauty. And it is this harmony, this blending of knowledge and wonder, that creates the soft, shimmering allure around the sixth planet. An allure that continues to unfold as the journey turns towards Saturn's orbital rhythms, its movements, and the gentle, unhurried flow of time that the planet keeps in the emptiness of space. From the layers of cultural and mythological meaning that have gathered around Saturn over thousands of years, the story of this planet doesn't remain confined to ancient texts or old illustrations of a weathered god of time. As those associations fade like night mist, what remains is Saturn's true rhythm in space, a slow, steady cadence written by its vast, sweeping orbit around the Sun. And from here, the narrative drifts into a new landscape, where distance, time, and motion become gentle currents that help the listener feel the ancientness of a faraway world. Saturn sits about 1.4 billion kilometers from the Sun, roughly 9.5 astronomical units. Across a distance so large it's nearly impossible to imagine, even light, the fastest thing humanity has ever known, must travel for more than an hour to cross the gulf between the Sun and the planet's pale, hazy cloud tops. When you picture light taking such a long stretch of time to arrive, the sense of distance brushes softly against the mind, as if reminding you that Saturn isn't just beautiful. It belongs to a quiet frontier of the cosmos, where time feels slower, and even an hour of sunlight becomes a tiny dot in eternity. In that immense expanse, Saturn makes its long journey around the Sun. A single Saturnian year lasts nearly 29.5 Earth years, long enough for an entire human generation to grow up, mature, and enter middle age, all while Saturn completes just one orbit. When someone turns 29, the planet has only just returned to the place it was when they were born, and by the time they reach 59, they can imagine Saturn having traced only 2 full paths around the Sun. Time, when viewed from the perspective of the 6th planet, stretches outward, quieter, gentler, like a long exhale from the universe itself. Saturn's orbit is almost circular, yet it carries a slight, subtle elongation, a small eccentricity that makes its path both steady and delicately shifting from phase to phase. Every motion along this orbit happens slowly and gracefully, like the measured steps of an ancient being that has existed for billions of years. There is no haste, no sudden change, only the quiet, reliable turning of a world deeply accustomed to its own long rhythm. Seen from Earth, that movement is nearly impossible to notice over days, months, or even years. Every shift, every drift requires spans of time so long it feels like watching the heartbeat of an old and patient cosmos. That slowness also appears in Saturn's seasons. With an axial tilt of about 26.7 degrees, close to Earth's, the planet experiences 4 distinct seasons as well. But each one lasts more than 7 Earth years. A single Saturnian summer stretches long enough for a newborn child to grow old enough to start elementary school. And a Saturnian winter lasts just as long, covering its pale yellow clouds in a chill that lingers for nearly a decade. Spring and autumn don't arrive quickly as they do on Earth. They unfurl into long, hazy transitions, stretching so far across time that the idea of a season feels softened, diluted into the vastness. You can imagine Saturn's broad orbit as a giant circle drawn around the Sun. Along this circle, the planet moves like a patient traveler, taking nearly 3 decades to complete the path. Each time the Sun's angle of light shifts, a new season begins to settle onto the planet. There are no forests or oceans like Earth's to reveal the turning of the seasons. Yet the tilt of the axis still guides the sunlight across different cloud bands, highlighting layers of the atmosphere and creating gentle variations in the planet's muted golden hues. Its great distance also means Saturn receives far less sunlight than Earth. Even so, the light that does arrive is enough to touch the icy particles in the rings, making them shimmer like suspended stardust. On that long, frigid orbit, Light becomes a kind of luxury, arriving slowly, spreading slowly, reflecting slowly. And the giant planet continues its journey, carrying its endless seasons and its unhurried revolutions. When you look at Saturn's orbit on a map of the solar system, it feels like a boundary line of endurance. Not too tilted, not too erratic, not wavering like an unpredictable curve. Its orbit is drawn from a balance of gravity and motion, a balance that has held steady for billions of years. And that very stability helps shape Saturn's character, a planet of time, of long cycles, of patience. When you weave together the cultural threads tied to the planet, the stories of the god of time, the astrological symbols of maturity, the ancient imagery found in art, and then turn back to Saturn's real orbit, you begin to see that science and symbolism seem to be saying the same thing. Both describe a world that moves on a slow rhythm, a world that lives in long cycles, a world where a single year lasts as long as a human childhood. From these mythic associations, the story gently sinks into the natural meaning written into the cosmos itself, where immense distances and stretched out time make every motion feel soft and unhurried. And as the tale comes to rest on Saturn's orbit, another door quietly opens, leading into the story of the planet's astonishingly fast spin, where the shortness of its days stands in complete contrast to its endless years, creating a beautiful paradox that makes Saturn all the more wondrous from every angle. As the journey drifts along Saturn's wide, unhurried orbit, the planet's sense of time feels stretched into something almost tender. A year nearly 3 decades long gives every motion around the sun the quiet tone of cosmic patience. But just when the mind begins to settle into that long, measured rhythm, Saturn reveals another fascinating paradox, a rhythm completely opposite, unfolding right on its cloud tops. From the slowness of its orbit, the story gently shifts to the quickness of its spin, as though this giant world lives with 2 heartbeats, one so slow it feels motionless, and one so fast it's almost unimaginable. In the vastness where sunlight takes more than an hour to travel from the sun to Saturn, time on this planet divides into 2 streams, the long stream of its years and the surprisingly short stream of its days. A single day on Saturn lasts only about 10.7 Earth hours, meaning the sunrise and sunset sweep across this enormous world in less than half a human day. If a child woke up one morning on Saturn and began an imaginary day, the sun would cross the sky and slip toward the cold horizon before lunchtime even arrived. The brevity makes each Saturnian day feel like a blink in cosmic time, a rotation so swift it feels delicate. Saturn's rotation speed is one of the most astonishing features of this gas giant. Spinning at extraordinary velocity, the planet completes a full rotation in under 11 hours, despite being nearly 9 times wider than Earth. Imagine a small model of Saturn turning in front of you, this massive sphere whirling so fast that calling it hurried becomes its own gentle paradox. Because even in that rush, the entire world still seems serene, almost dreamlike. Because of this rapid spin, Saturn cannot maintain a perfect sphere. Instead, it bulges at the equator and flattens at the poles, a classic oblate shape seen in many gas giants. You can picture Saturn like a soft ball being gently pressed at both ends while spinning quickly. Its equatorial radius is about 10% larger than its polar radius, a difference striking on a scientific level, yet one that adds to its natural beauty when viewed from afar. The shape makes the rings appear even more pronounced, like a radiant band wrapped around the planet's outward curve. This flattened shape isn't just a physical result. It's the story of balance between gravity and rotation, two forces always opposing yet cooperating to sculpt the final silhouette of a planet. On Saturn, the fast spin strengthens centrifugal force at the equator, pushing gaseous material outward, while gravity continues pulling everything inward from the poles. This constant push and pull shapes the smooth form we see when observing Saturn from deep space. But shape is not the only consequence of its fast spin. The constant motion of the atmosphere on a gas giant like Saturn is also heavily influenced by this rotation. On the cloud tops, streams of gas are pulled into swirling patterns by the planet's rapid spin, generating incredibly strong winds and storms spanning thousands of kilometers. When people imagine Saturn's winds, they often picture violent flows, but from a distance, its pale yellow bands feel far gentler. Though powerful beneath the surface, their motion looks like soft brushstrokes of color stretched across the equator. Listeners might imagine those bands as rivers in the sky, flowing smoothly, yet hiding the relentless spiral force carved by the planet's spin. As these currents are swept along, some regions accumulate energy and form enormous storms, like the massive tempests recorded in spacecraft data. But in this story, they appear only as gentle signals, mentioned softly, to guide the listener toward the next part of the journey, where Saturn's atmosphere and its storms will take center stage. If the long orbit and decades-long seasons give Saturn the aura of an ancient, patient elder of the cosmos, its rapid rotation makes it unexpectedly young and full of vitality. Taken together, the planet feels like a harmony of two opposites, stretched time and flashing motion. It's a balance found nowhere else in the solar system. When people picture Saturn, they often think of its glittering rings, yet it's the planet's fast spin that helps those rings remain thin, flat, and stable. If Saturn rotated slowly, the rings might warp, distort, or perhaps never form the elegant structure we see today. Its rapid spin creates the flattening needed to keep the icy particles in nearly perfect orbits, drifting like crystalline dust suspended in a silent dance. The shortness of each day also keeps atmospheric rhythms constantly shifting. Within a single rotation, sunlight warms certain regions briefly, then quickly changes angle as the planet spins. This creates subtle variations in temperature and gas density, contributing to large-scale patterns of winds, shaped almost like seasonal cycles, but driven by a day that lasts only hours. In that distant realm, Saturn's fast spin becomes a transformation, from cosmic stillness into continuous motion. If Saturn's orbit is the universe's long, steady breath, then its rotation is the quick, steady heartbeat full of quiet strength. Together, the two rhythms create a composition balanced between ancient calm and youthful energy. From the smoothness of this rapid rotation, the story will soon drift into the world of Saturn's atmosphere, where its cloud bands and storms appear like moving paintings, fierce yet peaceful in their own way, opening the next chapter in the exploration of a world whose beauty is truly one of a kind in our solar system. As Saturn's rapid rotation slowly quiets in the flow of thought, the idea of a planet turning itself in just under 11 hours brings a lightness, yet also a kind of quiet vigor. The contrast between its brief days and its endless years makes Saturn feel like one of the universe's hidden secrets. And from that rhythm of rotation, a natural question begins to open. Beneath those pale golden clouds, what forces are at work that allow this giant planet to keep its shape, its speed, and its endurance across billions of years? From the soft haze of its clouds, the story drifts inward, to a place where the atmosphere is only the doorway to the complex and wondrous layers within Saturn. Like Jupiter, Saturn has no solid surface to stand on or touch. It is a gas giant, an immense ocean of hydrogen and helium stretching from the outermost clouds down to unfathomable depths. If you could imagine placing a foot on Saturn, the sensation would be unlike any other planet in the solar system. There is no ground, no rock, no firm place to rest. Only layers of gas growing denser and more compressed the deeper you go, soft in appearance, but under immense pressure. It would feel like falling into an invisible ocean where every meter downward becomes a new stage of transformation, from light and airy to heavy and thick, until the gas behaves more like fluid than anything we experience on Earth. Saturn's composition reveals it as a kind of smaller version of the Sun. About 96% of the planet is hydrogen, the lightest and most abundant element in the universe. Around 3% is helium, an element often found in young stars. The rest is made up of faint traces of methane, ammonia, and water ice. Despite its enormous size, Saturn's makeup is simple and delicate, giving it the translucent beauty of a world with no solid boundaries. When compared to the Sun, the resemblance becomes striking. Both are built primarily from hydrogen and helium. Saturn is, in a sense, a miniature star, not massive enough to ignite nuclear fusion, yet large enough to preserve the qualities of primordial cosmic material. Beneath those gentle golden clouds, Saturn's structure unfolds like the layers of a colossal onion. At the center lies a small, solid, rocky core, possibly several times the mass of Earth. This core is thought to be the anchor of the planet's motion, a place where pressure and temperature rise so high that matter exists in forms found nowhere else in the solar system. Surrounding it is a layer of liquid metallic hydrogen, a strange and exotic state that emerges only under immense pressure. In this layer, hydrogen stops behaving like a gas and becomes a conductive liquid, similar to metal. This metallic hydrogen is believed to play a crucial role in generating Saturn's magnetic field. Beyond the metallic hydrogen lies a layer of liquid hydrogen and helium, where the material gradually becomes lighter, softer, and less dense, yet still far from anything we would imagine as a typical atmosphere. Beyond that, the gases spread outward until they blend into the cloud tops, the part we can observe from space. Layer upon layer, these strata stack into a world of continuous transformation, yet steady internal harmony. Saturn is immense, nearly 9 times Earth's diameter and more than 95 times its mass. Even so, its average density is lower than that of water, only about 0.69 geometry. This leads to a playful image. If there existed a cosmic ocean large and deep enough, Saturn would float like a giant sphere bobbing on its surface. It cannot happen in reality, of course, but imagining it brings a soft smile, like a moment of levity drifting through a vast scientific landscape. Its immense mass but low density reflect the truth that Saturn is made mostly of light elements. Inside the planet, the material is not compressed into rigid, rocky forms. It stays soft, in a physical sense. That softness is also why Saturn has the most pronounced flattening of any planet in the solar system. Its rapid spin pushes the equatorial regions outward, creating its characteristic oblate shape. The temperature and internal energy of Saturn tell another story, a quiet secret that science has only begun to uncover in recent decades. Saturn emits more energy than it receives from the Sun. This means processes within the planet are still generating heat. One hypothesis suggests Saturn is slowly contracting, and as it shrinks, that gravitational compression releases energy. Another, more intriguing idea involves helium rain. As helium separates from hydrogen and condenses into droplets, it falls toward the core, releasing significant heat along the way. These invisible showers quietly warm the planet from within, providing a steady source of energy that has lasted for billions of years. Imagine droplets of helium sinking through the deep layers, drifting slowly through liquid hydrogen toward the center, a delicate, almost peaceful image, yet one full of power. These silent rains may not thunder like rain on Earth, but they reveal a hidden, smoldering heart within the giant planet. Viewed as a whole, Saturn's interior structure feels like a downward journey, from lightness in the outer layers to intense compression at the core. Each layer contributes to the planet's rapid spin, its stable rings, its enormous winds, and its steady internal heat. And from these deep internal layers, the story will gently rise outward again, returning to Saturn's sky, where its pale atmosphere, soft cloud bands, and immense swirling storms paint scenes that feel both fierce and serene, creating some of the most unique and mesmerizing views in the solar system. Understanding the inside allows the outside to come alive with greater clarity and depth, continuing to lull the listener into a universe filled with both science and cosmic quietude. Beneath the deep layers where hydrogen becomes liquid metal, where helium falls as invisible rain, and where a dense rocky core compresses the ancient heart of the planet, it feels as though all of Saturn's inner workings hum quietly in the dark. From that depth, as the mind slowly rises upward, the gases grow lighter, softer, less dense, until finally they reach the outermost clouds. It is at this boundary, where space meets atmosphere, that the story shifts gently from the planet's interior structure to its outer skies, as if Saturn were opening a new chapter, one of color, of winds, and of movements that humans can observe from afar. Seen from space, the first thing to appear is the topmost cloud layer of Saturn. There is no land, no sea, no mountain, only broad stretches of cloud drifting like soft ribbons suspended in cosmic quiet. Their color leans toward a pale, creamy yellow, like the hue of an old candle glowing within a frosted glass lantern. Some regions fade into a gentle brown, forming smooth, delicate bands, not too bold, not too sharp. When sunlight touches them, the cloud tops reflect it with a muted glow that only tiny frozen particles can create. This gives Saturn the appearance of being wrapped in a thin golden veil woven from ancient ice and vapor. In this cloud layer, everything visible is only the outer shell of an exceedingly complex atmosphere. Saturn's atmosphere is threaded with bands that stretch parallel to the equator, similar to Jupiter's, though far less contrasting. These cloud bands are created by continuous streams of circulating gas. You can picture them as vast rivers of air flowing for thousands of miles from east to west. But each river has its own altitude, speed, and composition, forming stable stripes that endure over long stretches of time. The uppermost clouds are mostly made of ammonia crystals, frozen in Saturn's extreme cold, giving rise to the soft yellow tint we see from afar. Beneath the ammonia layer lie rare but substantial water clouds, formed where water vapor condenses under immense pressure in temperatures almost unimaginable. Deeper still is the layer of ammonium hydrosulfide, where the colors deepen toward a gentle brown. Each layer stacks atop the next, like pages in a book, every page with its own tone, yet blending together to shape the planet's quiet beauty. But the calm we see hides motion more powerful than anything on Earth. Saturn's winds are among the strongest in the entire solar system. Near the equator, they can reach speeds of 1 to 800 kilometers per hour, many times stronger than the most violent storms on Earth. And yet, from billions of kilometers away, these winds create no sound, no sense of chaos, only smooth, rounded streaks of color, like strokes of a soft brush across a colossal canvas. These winds arise from two major forces: the planet's rapid rotation and temperature differences between atmospheric layers. As Saturn spins quickly, its bands of gas are pulled into intense streams. But because the planet lacks a solid surface to create friction, the winds face almost no resistance. This allows them to sweep around the planet for tens of thousands of kilometers while maintaining extraordinary speed. Viewed from afar, that turbulence softens into beauty, like gentle ripples rolling across an enormous hidden lake. Deeper in the atmosphere, where pressure rises with every layer, stranger phenomena may take place. One of these is helium rain, droplets of liquid helium settling from the upper atmosphere and falling into the deeper metallic hydrogen zones. This rain is unlike anything imaginable on Earth. No sound of falling drops, no water, no dark storm clouds. It occurs in darkness, under crushing pressure and intense heat, silent, continuous, and vital for generating Saturn's internal warmth. Even farther down, where methane is squeezed under extreme pressure, another scientifically hypothesized phenomenon might occur: diamond rain. In those harsh conditions, methane may break apart into carbon, which can crystallize into tiny diamonds. These crystals would drift downward under gravity, falling like sparkling dust into the dense hydrogen layer below. No one has ever seen it. No spacecraft has captured it. But the possibility alone adds another layer of wonder, a fairy tale detail nestled inside planetary science. Every layer of gas, from the ammonia clouds to the deep, compressed regions of exotic chemistry, operates within a long-standing balance. Saturn's atmosphere is a blend of gentleness and intensity. On the outside, a serene pale gold. On the inside, powerful winds and invisible rains that have continued for billions of years. From afar, Saturn's cloud bands look like silk scarves, thin and soft, circling the planet as though weightless. But the deeper you look, into each layer, each stratum, the planet reveals itself as a structure full of strength. Yet in this sleepy tale, that strength is only a quiet accent, just enough to spark curiosity while preserving the soothing tone of Saturn's golden glow. And as the atmosphere opens up, those powerful winds seem to be guiding the listener towards stranger wonders. Titanic storms, mysterious hexagonal structures at the North Pole, and massive vortexes swirling in the dark. From this gentle yet ferocious atmosphere, the story is ready to drift towards Saturn's most extraordinary mysteries, where storm and geometry merge into some of the strangest sights in the cosmos. As the pale golden clouds of Saturn begin to take shape more clearly in the drifting flow of imagination, its atmosphere carries a dual feeling. On one side, it is gentle and serene, like ribbons of silk gliding slowly through space. On the other, it hides a fierce strength, with supersonic winds and mysterious rains no one has ever seen with their own eyes. From that quiet contrast, the story flows naturally into Saturn's most extraordinary phenomena, places where its atmosphere reveals a personality that is bold, unmistakable, and at times, almost mythic. From the calm, drifting clouds of the upper layers, the narrative opens a door into a world of colossal storms, where power and beauty intertwine to create visions that seem impossible, yet are entirely real. Every now and then, within Saturn's steady rhythm of rotation, its atmosphere awakens with a dramatic transformation. About once every 3 decades, roughly one Saturnian year, the planet produces a massive storm that lights up its entire hemisphere. This is the Great White Spot, the legendary planet-wide storm. Imagine a bright, sweeping streak stretching across Saturn's creamy yellow cloud bands, like a slash of pale fire suddenly appearing on the face of an otherwise gentle world. This phenomenon has been recorded across generations of observers, and each appearance marks a major shift in Saturn's atmospheric cycle. The storm can last for months or even years, circling the planet and spreading across tens of thousands of kilometers. In a universe filled with objects that remain steady and predictable, the Great White Spot is a soft reminder that even the most ancient worlds have moments when they stir awake, powerful, brilliant, and full of life. But if the Great White Spot is cyclical and sudden, another Saturnian phenomenon is long-lasting and almost unbelievably mysterious: the hexagonal storm at the planet's North Pole. No other planet in the solar system hosts anything like it. A perfect six-sided cloud pattern, stable over decades, unmoved by the constant churning of the atmosphere around it. The hexagon is not an illusion, nor a trick of light. Voyager 2 captured it clearly in 1981, and the Cassini spacecraft later confirmed its structure in exquisite detail. When imagined from above, Saturn's North Pole appears as if crowned by a giant, slowly turning six-petaled flower. Each side of this hexagon is longer than Earth's diameter, a scale so vast it demands a moment of stillness just to comprehend. Scientists believe this shape is formed by large, stable atmospheric waves, but its stunning precision continues to astonish. Under Saturn's soft golden glow, the sharp edges of the hexagon look like the border of an ancient emblem, etched into the planet's atmosphere since the beginning of its time. At the opposite pole, the South Pole, the atmosphere tells a different story. There is no strange geometry here, but instead a storm with a form far more familiar to us, a vast, swirling eye. When Cassini flew over Saturn's southern hemisphere, it captured an enormous circular vortex with a remarkably defined eye, almost identical to a terrestrial hurricane, but scaled up to the size of a giant world. The eye of Saturn's southern storm spans nearly 2,000 kilometers, large enough to fit the entire state of Texas with room to spare. And inside that eye lies a region of cold, deep, uncanny calm, a sharp contrast to the violent winds encircling it. These storms, from the Great White Spot to the northern hexagon to the southern hurricane eye, are not just atmospheric events. They are glimpses into Saturn's character, each one telling its own quiet story. The Great White Spot is the planet's slow but powerful heartbeat, returning once every Saturnian generation. The North Pole's hexagon is a testament to perfect balance and the strange elegance of fluid dynamics. And the southern eye is a symbol of depth, a place where stillness exists at the center of chaos. From afar, none of these storms make a sound. There is no thunder, no howling wind, only the soft blur of swirling clouds. In the grand picture, Saturn continues to drift through space like a serene giant, occasionally revealing bold, powerful features while maintaining a calm, almost regal composure. Its storms don't resemble disorder. They feel more like the deep, resonant notes of a cosmic lullaby, vast, majestic, and unhurried. A listener might imagine Saturn as a great living being holding both tranquility and strength within itself. Each atmospheric phenomenon is a symbol of that duality, a world that spins so fast it almost defies possibility, yet hosts storms that remain unchanged for decades. A world where winds reach unimaginable speeds, yet from space its clouds look soft enough to brush with a fingertip. a world that appears peaceful, yet hides an ocean of unsolved mysteries beneath its golden layers. And from these storms, the story of Saturn gently leads onward to its most iconic feature, the one that has made it a symbol of wonder for generations of skywatchers. Its exquisite ring system, radiant, delicate, and impossibly thin. Those rings, together with its storms, create an image instantly recognized by anyone who has ever looked up with curiosity. A portrait that has made Saturn the most beautiful planet in the eyes of humankind. Beneath the gentle light that spreads across Saturn's pale golden clouds, the planet's storms, from the Great White Spot to the northern hexagon and the southern hurricane eye, feel like slow, deliberate accents in the atmospheric symphony of the world. They are powerful, yet they never disturb its overall softness. They are mysterious, yet they never make Saturn feel menacing. Instead, each swirling cloud, each geometric edge, each circling vortex adds another subtle shade to the planet's portrait. And as these storms fade gently in the listener's imagination, something else emerges. Something almost inevitable. Beyond all tempests and spinning layers of gas lies the feature everyone thinks of first when Saturn is mentioned: its radiant system of rings. From storms to starlit halos, the story drifts like a soft breath, guiding the listener toward the most beautiful part of Saturn. When people think of Saturn, the image that rises in the mind is almost universal. A soft yellow sphere wearing a wide, luminous band, like a delicate brimmed hat resting lightly on its world. No other planet in the solar system possesses such a magnificent ring system. These rings make Saturn appear as if it's wrapped in a crystalline halo, floating quietly in the darkness of space. Among countless celestial bodies, this beauty has become a symbol. One glimpse, and anyone can tell they are looking at the sixth planet from the Sun. Yet when humanity first gazed upon Saturn through a telescope, its beauty was not nearly as clear as it is today. In 1610, Galileo Galilei became the first to see the signs of the rings. But with the simple telescopes of his time, he saw only two strange shapes flanking the planet, like two small ears or two moons pressed against its sides. He sketched the shape with quiet confusion. Saturn wasn't perfectly round like the other planets he had studied, but he could not have known he was actually seeing the edge of a vast ring system, transformed by limited optics and faint light into strange little appendages. It wasn't until 1655 that Christian Huygens solved the mystery. Using a better telescope, he realized that what Galileo had seen were not moons at all, but a wide, thin ring encircling the planet. That ring didn't touch Saturn. It floated around it, forming a structure unlike anything previously observed. This discovery opened the first chapter of ring studies, laying the groundwork for centuries of deeper investigation. As science advanced, humanity learned that Saturn's ring system is not a single band, but a collection of many. The largest and brightest rings are labeled A, B, and C, the most familiar and easiest to observe. Together, they form the iconic look of Saturn, with strong brightness and sharp structure. Between rings A and B lies the Cassini division, a darker gap about 4,800 kilometers wide, discovered by Giovanni Cassini in 1675. Later observations revealed additional fainter rings, D, E, F, and G, each with its own origin and characteristics. Saturn's rings stretch so far across space that they seem to occupy a vast region around the planet. The outer diameter of the ring system exceeds 270,000 kilometers, more than twice the diameter of Saturn itself. And yet, despite this breathtaking width, their thickness is astonishingly small. In many places, the rings are only a few dozen meters thick, with only a few hundred meters at their densest. Imagine a disk as thin as paper wrapped around a giant sphere. This contrast makes Saturn's beauty feel almost unreal. Despite their delicacy, the rings remain stable, held in place by gravity and the subtle interplay of countless icy particles. The material within the rings tells a story of its own. They are made mostly of pure water ice, mixed with small amounts of rock and dust. The particles vary immensely in size, some no larger than grains of sand, others as big as boulders. When sunlight touches them, millions of reflections scatter in every direction, creating a soft, shimmering effect like snowfall drifting across a night sky. From afar, the rings resemble a luminous ribbon of light gently embracing the planet, never harsh, yet never losing their quiet brilliance. Another remarkable truth is that the rings are always changing, though the eye can't detect the motion. The icy particles constantly collide, break apart, then gather again, forming temporary structures that rarely last long. But this ceaseless shifting gives the ring system the quality of a living structure, dynamic and ever in motion, yet appearing calm and eternal from billions of miles away. Across thousands of years, the rings have become Saturn's most recognizable symbol, a feature even children can identify instantly. They separate Saturn from the countless other worlds. It's not that other planets lack rings, but none have rings as wide, bright, and breathtaking as Saturn's. From early space illustrations, to children's songs, to posters on the bedroom walls of astronomy lovers, Saturn's rings hold a beauty that makes people pause, look a little longer, and feel their minds settle into the gentle quiet of the cosmos. And from this overview of a structure so delicate yet radiant, the story will soon expand into deeper details. The narrow gaps within the rings, the tiny shepherd moons that guide them, and the mysterious origins that may have formed, or may someday dissolve them. From external beauty, the narrative will move into the inner workings of one of the most extraordinary structures ever recorded in the solar system. As the delicate, glowing rings of Saturn begin to take shape more vividly in the listener's imagination, the story of that ring system becomes both familiar and mysterious. From the moment we picture them shimmering like a halo around the planet, we can already sense a portion of their surface beauty, vast, radiant, and fragile as a ribbon of light. And just as that image settles into a quiet stillness, the narrative can gently drift deeper, as though taking one soft step forward into the intricate structure that no unaided eye could ever uncover. From the broad picture painted earlier, the story now flows into the hidden details beneath that splendor, into the places where strange gaps appear, where tiny moons act as shepherds, and where the rings past may hold the tale of a moon torn apart. All of this opens a door into the detailed world of Saturn's rings, a world that is scientific, yet touched with the poetry of cosmic myth. When we look at Saturn's rings, the first impression is always one of smooth continuity, a single band of light encircling the planet, seemingly without interruption. But as spacecraft drew closer, and as Earth-based observation became more precise, we discovered that the ring system is far from continuous. Instead, it contains countless gaps, dark, empty spaces that separate parts of the rings as naturally and softly as well-placed pauses in a piece of music. The most famous of these, the Cassini division, is thousands of kilometers wide. It lies between the two brightest rings, A and B. From afar, this gap appears as a thin, graceful shadow dividing the luminous band into two balanced halves. And when we look even closer, we find that Cassini is not alone. There is also the Encke gap inside Ring A, a smaller division, yet still wide enough to hold a tiny moon. These gaps are not accidental, nor the result of any single ancient event. They are maintained by a remarkably delicate mechanism, the gravitational influence of small moons. These little moons have been given a gentle, almost affectionate name: shepherd moons. The name comes from their role. They move quietly inside or near the edges of the rings, using their gravity to sweep their paths clear. By pulling and nudging the icy particles, they prevent the ring material from wandering into places it does not belong. Like patient shepherds guiding their flocks, these moons keep the ring system from scattering. One striking example is Pan, a tiny, charming moon that lives inside the Encke gap. Though Pan is only a few dozen kilometers across, it can clear an entire ring gap thousands of kilometers long. In a similar way, Prometheus and Pandora act as shepherds of the F ring, a narrow but restless ring, constantly stretched and twisted by their gravitational tug-of-war. Because of this delicate struggle, the F ring remains beautifully chaotic, like a strand of silk caught in a gentle, ever-shifting wind. Yet Saturn's rings do not end with the Awodim, bright inner bands near the planet. Farther out lie faint, ghost-like rings that humanity might never have known without spacecraft. One of these is the E ring, a wide and misty band stretching hundreds of thousands of kilometers. This ring is fed and sustained by the water plumes erupting from Enceladus. Each time Enceladus sprays icy particles into space, those tiny crystals drift outward and join the E ring, turning it into a dynamic structure shaped by the moon's steady breath. Farther still lies the G ring, thinner and dimmer still, and at the outermost reach is the Phoebe ring, so vast it wraps around Saturn like an enormous cosmic cloak. This ring is made of dust shed by Phoebe, a distant moon with a backward orbit, believed to be a captured relic from ancient times. Looking at all these structures, a natural question arises. Where did Saturn's rings come from? There are two main theories, each telling a quiet but weighty story. The first suggests that the rings are remnants from the planet's birth. When Saturn formed, leftover material around it failed to gather into moons, remaining instead as countless small particles. Over billions of years, these became the rings we see now. This story paints the rings as fossils of a younger solar system, a soft reminder of the world's earliest memory, still circling in the present day. The second theory, more dramatic and emotional, suggests that the rings were once a large, icy moon. Long ago, that moon drifted too close to Saturn. The planet's immense tidal forces tore it apart, grinding it down into billions of fragments. These shards did not fall into the planet. Instead, they remained in orbit, forming a glittering, timeless memorial around Saturn. This vision gives the rings a quiet trace of tragedy, beauty born from the breakup of a world, a story etched into the long timeline of the solar system. Regardless of their origin, recent studies indicate that Saturn's rings may be surprisingly young, perhaps only 100 million years old, younger than Earth's dinosaurs. And there is a bittersweet truth: they will not last forever. The icy particles are slowly drifting into Saturn's atmosphere in a process called ring rain. In about another 100 million years, the rings may fade away entirely. But from the human perspective, a species living only tens of thousands of days in a universe of unending time, that span is more than enough for the rings to continue shining through many generations. And so, even knowing that the rings are slowly disappearing, the listener can still feel reassured, gently comforted. Throughout the lifetime of humanity, Saturn's rings will remain the most beautiful lantern in the cosmic dark. And as the story of the ring's delicate structure comes to a close, a new journey begins. For Saturn is not circled only by rings. Surrounding it is a sprawling family of moons, the largest moon system in the entire solar system, each with its own story, its own mystery, and its own quiet beauty waiting to be discovered. From the fragile rings shaped by countless tiny moons to the delicately carved gaps they maintain, Saturn's ring system feels like a long poem written in ice, stone, and sunlight. Each ring is a sentence, each gap a quiet comma, and each shepherd moon a gentle accent in that cosmic symphony. And as the story gradually drifts away from those bright ribbons floating around the planet, the narrative can softly shift into a different realm. Not something we see, but something that wraps around the entire planet like an invisible cloak. From the tangible beauty of the rings, the story steps toward the unseen power of Saturn's magnetic field, which surrounds the planet like a soft, giant garment stretching millions of miles into space. Although invisible, Saturn's magnetic field is a vital part of the planet's presence in the cosmos. If we imagine it as a massive bubble around the planet, that bubble, the magnetosphere, extends millions of miles outward. It is so vast that many of Saturn's moons orbit inside this magnetic envelope, like tiny dust motes gliding through a spacious room. And though Saturn's magnetic field is weaker at its surface than Earth's, because Saturn lacks a solid shell to anchor the field, the planet's immense size causes its magnetosphere to swell to an astonishing scale. This broad shield makes the space around Saturn calmer than the interplanetary region beyond, where the solar wind blows hard and unrestrained. To understand where Saturn's magnetic field is born, we must look deep within the planet, down to the place where hydrogen exists not as gas or liquid, but as metallic hydrogen, a strange form of matter that appears only under immense pressure. As Saturn spins rapidly, this layer of metallic hydrogen moves like a vast, electrically conductive ocean surrounding the core. And just as a spinning coil in a generator produces a current, the motion of this metallic hydrogen creates the magnetic field that cloaks the planet. This makes Saturn's interior feel like a silent, colossal dynamo, working endlessly in the dark, producing magnetic energy for billions of years without a single sound. And when the magnetic field interacts with the solar wind, the stream of charged particles blowing outward from the distant sun, a beautiful phenomenon unfolds: auroras. On Earth, auroras glow in greens, purples, and reds, shimmering across the night sky like silk curtains of light. On Saturn, they occur as well, but with a character shaped by the giant planet's nature. Observations from Cassini reveal swirling violet-blue rings of light encircling Saturn's poles, sometimes brilliant, sometimes dreamy, like lanterns glowing softly in the shadowed sky. Whenever the solar wind strengthens, Saturn's auroras brighten, performing a slow, patient dance only the most attentive observers can fully appreciate. Auroras are not just lights. They are signs of an invisible conversation between the planet and the sun. A quiet exchange that makes Saturn's atmosphere seem illuminated from within. And the mystery deepens when we learn that Saturn's magnetic field can also create sound. Not sound traveling through air, but radio waves that can be converted into audible tones. During its long mission, the Cassini spacecraft recorded unusual radio signals coming from Saturn's rings and magnetic environment. When translated into sound, they resemble long hums, soft rumbles, or whisper-like tones, as if the planet were sharing a private melody. These sounds do not pulse in steady rhythms. Instead, they flow in gentle rises and falls, shaped by shifts within the magnetic field. A patient listener might experience them as a story told through sound, without words, without images, only quiet interpretation and a mind ready to drift. Beyond creating auroras and mysterious sounds, Saturn's magnetic field serves as a natural shield, protecting the region around the planet from streams of charged solar particles. Inside this expansive magnetosphere, many of Saturn's moons are sheltered from radiation that might otherwise erode their surfaces or strip away their fragile atmospheres. Even though Saturn lacks a solid surface, its magnetic field behaves like a protective gesture, an arm encircling its many moons. Because of this, the space around Saturn holds a distinct stillness, like a pocket of calm sheltered from the wild winds of the cosmic sea. Seen in full, Saturn's magnetic field is one of the elements that bring harmony to the entire system. From a hidden core no one can see to the vast reaches of space surrounding the planet, the magnetic field ties Saturn's layers together. It creates glowing auroras, stabilizes the orbits of moons, and produces strange sounds that scientists are still working to decode. And when we imagine that vast magnetic bubble stretching millions of miles outward, we can feel the story expanding naturally. For within that bubble lies not only Saturn and its rings, but an entire family of moons, so many that they form the largest moon system in the solar system, almost like a miniature solar system of their own. Each moon has its own personality, its own history, its own quiet beauty, from icy worlds to dark, shadowed spheres, from Titan wrapped in haze to Enceladus, sparkling with water jets. And it is among these moons, drifting slowly within Saturn's magnetic embrace, that the story gently turns to its next chapter. The exploration of the most populous family of moons in the solar system. Wrapped around Saturn, the planet's vast magnetic cloak stretches millions of miles outward like an invisible embrace, preserving a deep stillness in the space nearby. Within this protective cocoon, violet-blue auroras dance at the poles. Radio whispers hum softly like secrets from the universe, and streams of charged particles bend into quiet, hidden pathways. Imagining all of this at once, the listener can begin to sense Saturn not merely as a planet, but as the center of a world unto itself, where the magnetic field protects not only the planet, but everything that circles around it. And just as the mind is lingering in the glow of those polar lights, the story shifts naturally toward the planet's many companions, its moons. The magnetic field surrounds them, and in return, they help define the character of the entire Saturnian system. And so, from a story of invisible light and drifting particles, the narrative opens gently into a world of shapes, colors, and histories of its own. The world of the largest moon family in the solar system. Among all the planets in the solar system, none possesses a family of moons as numerous and diverse as Saturn. As of 2025, astronomers have confirmed 274 moons orbiting the giant planet. The number is almost hard to believe. Yes, 274, more than double the total moons of all the other planets combined. Saturn's system becomes, in a sense, a miniature solar system of its own, a central world surrounded by hundreds of smaller ones, each following its own orbit yet moving together in a shared cosmic rhythm. However, most of those 274 moons are not large worlds one can easily picture. Many are simply small, icy rocks, only a few kilometers across, sometimes rounded, sometimes jagged like ancient fragments never smoothed by time. They are so small that placed on a map of Earth, many could fit comfortably inside a canyon or rest quietly on a single field. Yet despite their size, they still follow the gravitational choreography of Saturn, patiently orbiting their parent planet in paths that vary from nearly perfect circles to long, stretched ellipses, depending on their origins. Diversity, that is the truest word to describe Saturn's moons. Some are large spheres with smooth surfaces or cratered shells, reflecting sunlight with remarkable brightness. Others are tiny and rugged, resembling captured asteroids. A few moons drift so close to Saturn that they glide within the gaps of the rings, like Pan or Daphnis. These are called the inner moons, circling near the planet and interacting directly with the ring system. Farther out lie the medium and large moons, Rhea, Tethys, Dione, worlds big enough for their own gravity to shape them into spheres. And even farther still, some moons orbit backwards, opposite Saturn's rotation, hinting that they may have been captured from distant reaches of the solar system long ago. Each group of moons carries the story of its origin. The innermost ones may have formed from the same material as the rings. The larger spherical moons likely formed from the original disk of gas and dust surrounding Saturn during its birth. Meanwhile, the retrograde moons may have traveled inward from the solar system's outer edge, relics of the Kuiper Belt, or wandering objects caught forever in Saturn's gravity. The relationship between Saturn's moons and its rings runs deep. Some small moons carve the gaps in the rings by sweeping away icy particles along their paths. Others contribute material to the rings themselves. The clearest example is Enceladus. Its southern geysers spew fine ice grains into space, and these tiny particles drift outward to replenish the E-ring, giving it a wide, misty glow like a faint halo drifting in orbit. Farther out, the moon Phoebe sheds dusty material that forms the enormous, shadowy Phoebe ring, wrapping the entire Saturnian system like a distant veil. In another fascinating corner of Saturn's realm, there exists a pair of twin moons, Janus and Epimetheus. They share nearly the same orbit and perform a remarkable gravitational dance. Every few years, the two moons exchange places, as though passing roles in a slow, celestial duet. They never touch, yet constantly influence one another, maintaining a distance that feels both safe and intimately close. The image evokes twin figures from myth, forever paired, forever separate. Indeed, many of Saturn's major moons bear names from Greek mythology, the Titans and the ancient giants. Titan, Rhea, Iapetus, Tethys, Dione, Hyperion, Enceladus. Each name opens the door to an old story. These names lend the Saturnian system a layer of mythic charm, as though each moon were given a title to preserve a fragment of ancient lore across the sky. Among this immense family, two moons stand out so strongly that they deserve entire chapters of their own: Titan and Enceladus. One is a giant world veiled in orange haze, home to lakes of methane and rains colder than any winter on Earth. The other is far smaller, bright, icy, and alive with water plumes that hint at a warm ocean hidden beneath its frozen crust. Both hold some of the most intriguing clues about the possibility of life in the solar system. And from this broad overview, the story will begin to draw closer to these two worlds. From the sweeping picture of 274 moons, the narrative will gently zoom in. First to Titan, the amber jewel in the fog, then to Enceladus, the crystalline moon that sprays glittering jets into space. These two moons, each wondrous in its own way, make Saturn's exploration feel like leafing through the chapters of a long cosmic novel, each page offering a new, quiet surprise. As the wide portrait of Saturn's family of moons begins to take shape, with hundreds of small worlds circling their parent planet. Each moon feels like a tiny piece in a vast, multicolored astronomical mosaic. And in that growing image, the listener can sense that not all moons are alike. Some are no larger than a cluster of boulders, drifting quietly along narrow orbits. Others are grander, older, bearing the scars of the solar system's early days. Then, as the mind continues to drift along Saturn's gravitational embrace, a name begins to surface, a name always spoken with a certain reverence. One moon stands out among the hundreds, glowing like an amber gem floating in thick haze. In that soft transition, the story naturally guides the listener towards Saturn's most magnificent moon, Titan, a world entirely its own, deep as a dream, yet filled with scientific data and unanswered mysteries. If any moon in the solar system deserves to be called the shining star among the worlds orbiting their host planets, it is Titan. Titan is massive, comparable to small planets. Its diameter is even larger than Mercury's. But what makes Titan truly remarkable is not its size, but the thick atmosphere that covers its entire surface, something no other moon possesses. From afar, Titan looks like a muted orange sphere. Its surface is completely hidden beneath a dense haze that barely allows light to pass through. Because of this, Titan does not resemble an icy or rocky moon like most others. It looks instead like an ancient, dusky world suspended inside a deep, amber fog. This mystery makes Titan one of the most compelling destinations for scientists. Not because it is beautiful like Saturn, but because Titan may harbor chemical and geological conditions utterly unlike anything seen elsewhere. Titan's thick atmosphere is the first breathtaking feature. Its surface pressure is about 50% higher than Earth's. This means that if you were standing on Titan, the weight of the air pressing on your body would be noticeably stronger than at home. Most of the atmosphere is nitrogen, about 98%, with the rest made of methane and other hydrocarbons. These molecules form the orange smog that wraps around the moon, absorbing sunlight and masking the surface from view. Many scientists compare Titan's haze to what early Earth might have looked like: thick, chemical-laden, and forever filtering sunlight through a heavy veil. But beyond the haze lies another astonishment. Titan's landscape is eerily similar to Earth's. Titan is so cold, around 290, that water behaves like rock. But methane and ethane, under these frigid conditions, behave like water does on Earth. They create rivers, they carve channels, they fall as rain. They fill seas and lakes that stretch for hundreds of miles. Imagine standing on Titan, a scene no human has ever witnessed firsthand. The sky is dim and hazy, washed in soft orange. Light filters weakly to the ground. The cold air stings with a silence so complete it borders on dreamlike. Below the dense haze lie plains coated in ice, crossed by slow, dark rivers of liquid methane. Raindrops of methane fall, heavy, frigid, tapping against the still surface of distant lakes in Titan's deep, frozen quiet. Together, these features create the picture of a world both strange and hauntingly alive in its own way. Humanity had long wondered about Titan's surface, but it wasn't until 2005 that we saw it for the first time. That was when the Huygens probe, released from the Cassini spacecraft, descended through Titan's murky atmosphere. Huygens drifted slowly through the thick layers of haze, capturing the first images ever taken from the surface of a moon with a substantial atmosphere. Those images revealed scattered ice rocks, dried riverbeds, and landscapes that looked like places once shaped by flowing liquid, if that liquid were not water, but methane. It was a landmark moment in space exploration. the first time humanity laid eyes on the ground of such an alien, atmospheric world. From these discoveries, a profound question began to take shape. Could Titan harbor life? Not life like Earth's, because liquid water cannot exist at such low temperatures, but perhaps life that uses methane instead. Methane-based life is speculative, yet not impossible. Titan has complex organic molecules, methane, chemical energy sources, and deep lakes of liquid hydrocarbons. Some chemical models even suggest that Titan could produce molecules intricate enough to form the foundation of life. These mysteries led to the creation of a new mission, Dragonfly, scheduled to launch in 2027. Dragonfly is not a traditional lander. It is a flying drone, capable of lifting off and traveling across Titan's surface, exploring multiple regions Huygens could never reach. If all goes well, Dragonfly will arrive in the 2030s, opening an entirely new chapter in our understanding of distant worlds. It will search for complex organics, sample sediments, analyze the atmosphere, and possibly, just possibly, detect hints of an exotic form of life hidden within Titan's methane lakes. And as Titan comes into view, familiar in shape but alien in substance, the story gently turns toward another moon, smaller, brighter, yet carrying a secret just as deep. Enceladus, where plumes of water erupt from an underground ocean, may hold the clearest clues to extraterrestrial life that humanity has ever encountered. As Titan slowly rises in the imagination, like a dim, amber world wrapped in mist, its silent methane seas and dense atmosphere veiling it like a half-remembered dream, the story of Saturn's eldest child begins to feel like stepping into a place where science brushes against fairy tale. Titan is vast, mysterious, and rich in chemistry, as if guarding faint clues to a kind of life humanity has never known. Yet while Titan is immense and heavy with possibilities, just beside it lies a moon far smaller, quiet, humble at first glance, yet hiding a secret even more daring. From Titan's amber haze, the narrative drifts gently into a whiter, colder glow. A sparkling shard of ice gliding beside Saturn, a tiny moon carrying a resonance far larger than its size. And so, from Titan's warm dusk, the story softens and turns toward a brighter white, Enceladus, Saturn's enigmatic frozen jewel. If Titan feels like a doorway into an ancient chemical past, then Enceladus is a whisper from the future, a place offering hope that life might endure in the most distant, frigid corners of the cosmos. Enceladus is so small that many would assume there's nothing remarkable about it. Its diameter is only about 500 kilometers, far smaller than Earth's moon. But the moment sunlight touches Enceladus, every assumption of ordinariness dissolves. The surface of Enceladus is so pure and bright, it almost seems to glow from within. Its icy shell reflects up to 99% of the sunlight that falls upon it, making it one of the brightest bodies in the entire solar system. From afar, Enceladus looks like a perfect snowball drifting through deep space, as if carved from untouched ice that time has never managed to dim. No dark dust, no ancient scars like those etched across many older moons. Nothing but a cold, white silence so pristine that anyone who looks at it can't help but feel they're witnessing one of nature's purest creations. But that beauty is only the surface. Beneath that still, frozen crust, Enceladus is far more active than anyone ever expected. In 2005, when the Cassini spacecraft flew over Enceladus's south pole, it discovered something that completely reshaped our understanding of the moon. From long fractures, deep blue lines called tiger stripes, gigantic plumes of vapor and icy particles were erupting into space. They were like cosmic hot springs, geysers shooting in bright white columns hundreds of kilometers high, before falling back or drifting outward to become part of Saturn's E-ring. Under sunlight, those icy jets shimmered like threads of silver. Their presence made Enceladus one of the most breathtaking discoveries in all of planetary exploration. And those plumes were hints of something far greater. Beneath Enceladus's thick ice lies a vast ocean of liquid water. It isn't open to the sky like Earth's seas, but hidden under tens or even hundreds of kilometers of ice. Yet thanks to Saturn's powerful tidal forces, pulling and squeezing the Moon again and again, the water beneath remains warm enough to stay liquid, forming a deep, shadowed ocean where sunlight can never reach. Imagine it. Beneath that quiet shell lies a dark, far-stretching sea where liquid water drifts slowly through eternal night. There may be hydrothermal vents there, hot, mineral-rich chimneys like the ones on Earth's ocean floors, where life first emerged billions of years ago. If such vents exist on Enceladus, then its ocean could have the chemical environment needed to sustain microscopic organisms. Not complex creatures, not whales or kelp forests, but perhaps the simplest living cells. And even that would transform everything we know about life's place in the universe. What makes Enceladus such a strong candidate for life is what Cassini found inside those icy plumes. When the spacecraft flew through the erupting particles, it detected simple organic molecules, molecular hydrogen, and sea salts. These ingredients closely resemble the environment that Earth's seafloor life depends on. The hydrogen especially is a crucial sign. It suggests that geochemical reactions between water and rock may be occurring below the ice, providing a direct chemical power source for possible life. The ocean, the chemistry, the energy from tidal forces, together they make Enceladus one of the most promising places anywhere to search for life beyond Earth. In a vast solar system where most worlds are too cold, too dry, or too scorched, Enceladus becomes a quiet surprise, a frozen crystal world that somehow shelters warmth on the inside. And perhaps the most magical thing about Enceladus is this contrast. A tiny moon, seemingly unremarkable, turns out to be far more alive with activity than nearly anyone imagined. Enceladus drifts silently around Saturn, yet it continually sends out plumes of icy snow, as if whispering messages from its hidden ocean. Each eruption is like a small reminder that the universe is still full of untouched mysteries. Looking at Enceladus, we are reminded that the most extraordinary worlds are sometimes the ones we overlook at first. And from that place, a little moon shining like crystal, sheltering an ocean in its quiet depths, the story will gently move onward toward the rest of Saturn's moons, each with its own shape, its own secrets. But for a moment longer, Enceladus remains, glowing softly in the mind, one of the brightest candidates for life, a delicate ice-born gem drifting in the embrace of a giant world. From Enceladus, where silent cosmic snow plumes drift up through fractures in its white ice, the story opens into a feeling of standing before a world so small, yet larger than imagination allows. From Enceladus's deep, shadowed ocean, the mind can drift gently toward the other landscapes of Saturn's moon system, each with its own personality, its own distinct kind of beauty. If Enceladus is the perfect crystal of ice, the remaining moons resemble strangely colored gemstones, weathered by time yet filled with ancient stories. And from that pure white glow, the narrative enters a diverse garden of satellites, where every name carries its own history, its own secret. Among them are moons split into two colors, moons shaped like giant walnuts, moons that look like battle stations from science fiction, and tiny bodies tumbling unpredictably like cosmic dust. Together, they form the rich and varied family portrait of Saturn's satellites. In that portrait, Iapetus is a world impossible to overlook. It may be the strangest moon Saturn possesses, a cosmic yin-yang in orbit. One hemisphere of Iapetus shines bright, reflecting sunlight like a familiar frozen moon. But the other half is nearly pitch black, as though coated in fine charcoal that swallows every ray of light. Imagined from space, Iapetus appears like a two-toned glass bead, one side shimmering, the other melting into darkness. The split creates the sense of two worlds fused together, forever circling Saturn yet never blending into one another. The most likely cause of this striking contrast is that Iapetus collects dust from Phoebe, a distant and far older moon. As particles from Phoebe settle onto Iapetus, they gradually coat one side in that distinctive dark layer. But that's only part of the story. Running along Iapetus's equator is a mountain ridge stretching thousands of kilometers, rising like the spine of a massive creature. This ridge gives Iapetus the appearance of a rugged walnut floating through space. Nowhere else in the solar system has anything like it, and its origin remains a mystery still waiting for answers. Leaving Iapetus behind, the story turns toward three quieter sisters, Rhea, Dione, and Tethys. All three moons are cloaked in white ice, bearing a simple beauty shaped by the long, patient work of time. Rhea, Saturn's second largest moon, has a surface densely packed with impact craters. They cover it from pole to equator, like ancient scars marking billions of years of collisions with wandering rocks. Another curious feature: Rhea may possess an extremely thin atmosphere made almost entirely of oxygen, so faint it is nearly undetectable. Dione, one of the brightest and loveliest of the icy moons, carries sweeping bright streaks across its trailing hemisphere, signs of old fractures dusted with ice particles. Tethys hosts the Great Canyon Ithaca Chasma, stretching some 2,000 kilometers across its surface, a giant fracture that seems to split the world in two. These three moons have no geysers, no vast underground oceans, no thick atmospheres, but they carry the beauty of stillness. Across their wide, icy plains, time seems to hold its breath. No winds, no noise, only a silence that has lasted for billions of years. They feel like perfect fragments of the solar system's early history, preserving every mark they have ever endured. After this long quiet, Mimas brings a touch of cosmic humor. Mimas is famous for looking exactly like the Death Star from Star Wars. This connection isn't accidental. It comes from Mimas's enormous impact crater, Herschel, which spans nearly 1/3 of the moon's entire diameter. Its steep walls and central peak make Mimas look like a natural version of the iconic movie fortress. Yet behind that dramatic appearance, Mimas is a cold, likely geologically dead world. No internal activity, no geysers, no hidden sea, only ice, craters, and stillness. Hyperion, on the other hand, is unlike any of them. It's not round or symmetrical, but lumpy and porous, like a giant sponge drifting through space. Its surface is filled with deep, oddly shaped pits, giving it the look of a tumbling charcoal honeycomb. Even more unusual, Hyperion rotates chaotically. It has no stable spin axis, no predictable orientation. Each day on Hyperion turns in a different direction, making it feel like a world half asleep, swaying through its own peculiar rhythm. And then there is Phoebe, a distant moon orbiting backward relative to most of Saturn's moons. Phoebe is dark, rough, ancient, with a wide, elongated orbit. Scientists believe Phoebe may have been captured from the Kuiper Belt, the remote region where the solar system's earliest leftovers still linger. If so, Phoebe is a true relic, carrying stories that date back before the giant planets fully formed. And Phoebe is not alone. Hundreds of tiny moons, some only a few kilometers wide, also drift around Saturn, forming a boundary region of chaos and abundance. These small moons are like oversized grains of cosmic dust, sometimes embedded in the rings, sometimes wandering farther out, all moving in one vast, slow dance around their parent planet. Taken together, Saturn's moon system appears like a miniature version of a solar system. Not only is there the great planet with its beautiful rings, but also hundreds of moons, large and small, each with its own personality and its own history. From the massive satellites to the smallest rocky fragments, all blend into a quiet symphony of orbital motion. And in that slow, gentle dance, we're reminded of something simple. The universe is vast, but every world, large or small, has a story of its own, from the crowded portrait of Saturn's moons, from the two-toned Iapetus, the quiet Rhea and Dione, to the tumbling Hyperion and the ancient Phoebe. The sense of a vast satellite family circling Saturn becomes whole. Each moon carries its own presence, like silent characters standing still in the calm of the cosmos, telling stories etched into their surfaces over billions of years. Yet even though these moons have been there since the dawn of the solar system, humanity has only truly seen them clearly in the past few decades. From Earth's vantage point, they were merely tiny dots of light. Only when we sent spacecraft into the deep darkness of space did Saturn's system begin revealing its details. And so, after wandering through the worlds of the moons, the story gently drifts toward the first missions, humanity's earliest steps in approaching the planet with the beautiful rings. From the quiet of hundreds of satellites, the narrative glides toward the journeys of small, courageous spacecraft that opened the age of Saturn exploration. When we speak of the first encounter with Saturn, the name that rises first is Pioneer 11. In 1979, Pioneer 11 became the first human-made mission to come close to the giant planet. The small spacecraft, no bigger than a table and carrying instruments that now seem humble by modern standards, traveled for years through the cold emptiness of the solar system before finally arriving. Imagine that little probe, a tiny metallic speck, drifting through the endless dark, headed toward a planet humanity had only glimpsed through telescopes. As Pioneer 11 swept past Saturn, it sent back the first photographs, grainy, noisy, far from the crisp clarity of modern imagery, yet precious beyond measure. In those frames, Saturn's rings appeared as thin, delicate arcs of light, and the spacecraft discovered an additional faint ring, later named the F ring. Pioneer 11 also measured the radiation environment around Saturn, helping scientists understand the hazards future missions might face. Everything Pioneer 11 witnessed happened within a few short hours. But what it returned opened the very first doorway toward a world humans had only imagined. Not long after Pioneer 11, two successors were sent, Voyager 1 and Voyager 2. If Pioneer 11 was the first light tap on Saturn's door, the Voyager missions were far deeper, fuller, and more revealing encounters. Voyager 1 arrived at Saturn in 1980 with a clear goal: approach Titan, the largest and most mysterious of Saturn's moons. As it flew past Titan, it felt as though all of humanity was waiting for the first glimpse of that hazy orange surface. But Titan kept its secrets. Its thick, hydrocarbon-clouded atmosphere hid everything beneath. Voyager 1 saw only a soft orange sphere, featureless, and Titan remained shrouded in mystery for decades to come. After the Titan flyby, Voyager 1 used Saturn's gravity to bend its trajectory upward, leaving the plane of the solar system and beginning its long journey toward interstellar space. Its path diverged into a new story, away from Saturn, into the endless, quiet dark. 1 year later, Voyager 2 reached Saturn. This visit brought back a far richer trove of images and data. Voyager 2 captured close-up views of moons like Mimas, Enceladus, Iapetus, and Rhea, revealing craters, fractures, and bright streaks that had persisted for billions of years. It also discovered many new small moons hidden within the ring system. And within the rings, Voyager 2 detected strange features. Dark spokes appearing across the B ring. Faint streaks that looked as if someone had brushed them with static dust. These markings would be explained only years later, but at the time, they were beautiful puzzles shimmering inside the glittering rings. Voyager 2 identified small gaps between the rings, such as the Keeler Gap, and confirmed the existence of shepherd moons, tiny satellites whose gentle gravitational pull keeps ring particles in line. Details once invisible from Earth now appeared as clearly as raised patterns on a giant sculpture. Although Voyager 1 and Voyager 2 spent only days around Saturn, never staying, never orbiting, their brief visits changed humanity's understanding forever. Before the Voyager missions, Saturn was simply a pale golden point with rings, a lovely but distant mystery. After Voyager, Saturn became a fully detailed world, rich, layered, home to hundreds of moons, intricate ring structures, and atmospheric complexity beyond imagination. And so, those early missions are remembered as the Pathbreakers. Pioneer 11 was the first spark of light shining into an unknown region. Voyager 1 and Voyager 2 were larger lamps, illuminating every moon, every groove, every icy grain in the rings. Thanks to them, humanity could look at Saturn not only through imagination, but through real images, real measurements. From those quick flybys, a new era began. The door had opened, and people longed for a mission that could linger, one that would stay, watch, observe Saturn through its seasons, its storms, its moons, not for days, but for years. And from that longing, the story moves toward the next chapter. Cassini-Huygens, a triumph of science and perhaps the most beautiful love letter humanity has ever sent to Saturn. From the earliest visits of Pioneer 11, then Voyager 1 and Voyager 2, the thin veil covering Saturn was lifted little by little. The faint glowing dots, the soft outlines in those first photographs, the surprising discoveries of gaps within the rings and tiny moons tucked between them. All of it formed humanity's earliest foundation for understanding the most beautiful ringed world in the solar system. But because those flybys passed so quickly, they left behind a sense of incompleteness, as though we had only glanced at a grand painting without the chance to pause and absorb every detail. When Voyager 2 departed Saturn and continued outward, one lingering question remained. What would happen if a spacecraft could actually stay with Saturn, truly live beside it, not for a few hours or a few days, but for many years? What might emerge if we could observe every season, every storm, every moon in full? And from that open space, the story gently shifts toward humanity's largest, most ambitious, and most beautiful mission to Saturn. Cassini-Huygens, the journey that stretched across more than a decade within those shimmering rings. Cassini-Huygens, launched in 1997 and arriving at Saturn in 2004, was the result of a partnership between NASA, the European Space Agency, and the Italian Space Agency. It was more than a probe. It was a monumental scientific creation, sent to fulfill the most complete dream humanity had ever held for understanding Saturn. Cassini carried an array of intricate instruments to study the planet's magnetic field, its atmosphere, its rings, and its many moons. Attached to it was the small Huygens lander, built for one unprecedented goal: to touch down on Titan, the mysterious moon wrapped in orange haze. When Cassini entered Saturn's orbit in 2004, a new era of exploration began. Over 13 years, Cassini circled Saturn more than 290 times, a number that could fill an epic of patience, devotion, and scientific love. The spacecraft drew close, then drifted away, repeating that rhythm dozens of times, each pass opening another chapter in Saturn's story. What Cassini returned was not just data, it was a collection of windows into worlds we had only imagined before. With its radar, Cassini pierced the haze of Titan and revealed lakes and seas of liquid methane, dry riverbeds, valleys, and dunes, a landscape both strange and familiar, like an icy, distant version of Earth. It flew through Enceladus's plumes again and again, diving straight into the icy spray to analyze its chemistry, confirming the existence of the moon's hidden ocean beneath its frozen crust. Cassini also approached Saturn's stranger moons: Hyperion, porous like a giant sponge; the two-toned Iapetus, crowned by its mysterious equatorial ridge; and Pan and Atlas, tiny moons shaped like flying saucers drifting quietly inside the rings. Each image Cassini sent home felt like a gentle gift, unfolding yet another story within Saturn's collection of cosmic oddities. Among the most unforgettable moments came on January 14, 2005, when the Huygens probe separated from Cassini and began its descent to Titan. Through the dense orange haze, Huygens slowly drifted down, sending back the first sounds ever recorded from another world: the soft whisper of wind. When it reached the cold surface, the first images showed Titan's flat horizon and scattered icy rocks lying still like ancient tales frozen in place. Huygens operated for only a few hours before falling silent forever, becoming part of Titan itself, as if having fulfilled its mission, it chose to remain in that distant world. One of Cassini's most beautiful images was captured in 2013, Saturn eclipsing the Sun. From behind the giant planet, Cassini saw the rings ignite in delicate golden light, stretching outward like an enormous silken halo. And in a tiny corner of the image, faint and blue, was Earth, our home, the size of a dust mote. A small pale dot in the darkness, reminding us of our fragility and the way every person, every story, every memory is held within that single shimmering point. Then, in 2017, Cassini entered its final chapter, the grand finale. The spacecraft performed daring dives through the narrow gap between Saturn and its innermost rings, regions no spacecraft had ever explored. Each dive was a leap into the unknown, and Cassini completed dozens of them, revealing new details about the ring's structure, the magnetic field, the atmosphere, and the layers of Saturn's cloud tops. And then, on September 15, 2017, Cassini ended its journey. It entered Saturn's atmosphere, burning slowly, dissolving into the pale golden clouds it had watched for so many years. Its farewell felt less like an ending and more like a soft goodbye, a shooting star returning to the planet that had become its home. The legacy of Cassini-Huygens has never faded. More than 600 gigabytes of data, over 400,000 images, and countless discoveries that reshaped humanity's understanding of Saturn and its moons continue to be analyzed today. Cassini's mission ended, but the story it left behind lives on in every study, every image, every new idea about life beyond Earth. And from this chapter filled with light and emotion, the story will gently drift toward the final part: the future of exploring Saturn and the dreams humanity still holds for the most beautiful ringed planet in the solar system. From the radiant, emotional journey of Cassini-Huygens, the story of Saturn seems to slow down, opening into a tender quiet. After the spacecraft dissolved into the pale yellow layers of Saturn's clouds, leaving behind a treasure of knowledge and memory, people found themselves looking not only back with gratitude, but forward with renewed hope. The end of Cassini was not a final period in humanity's curiosity about the most beautiful ringed planet in the solar system. Instead, it was a soft comma, a gentle pause leading into another chapter, where great questions still linger, waiting to be answered by the missions that will follow. From the moment Cassini vanished into Saturn's hazy atmosphere, the story naturally shifted toward an open future, where dreams of exploration continue to glow quietly. In the not-too-distant future, one of the brightest hopes carries the name Dragonfly, a rotorcraft lander that will fly to Titan in the 2030s. Dragonfly will not simply touch down on Titan as Huygens once did. It will lift off again and again, gliding from place to place, exploring wide regions with a capability no other spacecraft beyond Earth has ever possessed. Titan, with its methane seas, towering sand dunes, and frigid plains, will become the playground of this mechanical dragonfly, allowing it to investigate complex organic chemistry and perhaps even trace the faint clues of early life. In Titan's gentle stillness, Dragonfly will quietly gather the small signs hidden in its atmosphere, on its surface and within its organic compounds, all to answer a profound question. Could Titan be a natural laboratory of the cosmos? Not only Titan, science is also looking toward Enceladus, the tiny ice jewel with its deep, hidden ocean. Future missions may try to collect samples directly from the plumes erupting at Enceladus's south pole. By capturing just a handful of those icy particles and analyzing them with great care, humanity might uncover evidence of microbial life, or at least complex organic molecules, suggesting that energetic chemical reactions are unfolding in the darkness of its subsurface ocean. Perhaps one day, a new spacecraft will glide through those icy geysers, extending a small sampling arm to gather each microscopic shard. And perhaps those shards will hold the answer humanity has been searching for across centuries. Are we alone in the universe? Farther into the future, people dream of even bolder missions. A craft that could float through Saturn's atmosphere itself, drifting like a great wind sail among its creamy golden clouds. Such a machine could feel the winds directly, measure atmospheric composition, and sense the deep currents far below what orbiters can reach. Imagine a lightweight vessel gliding through Saturn's layered mists, like a metallic leaf carried by soft but powerful winds. It is a vision both scientific and poetic, a reminder that exploring the cosmos is not only about numbers and data, but also about imagination and courage woven together. Though Cassini opened a new era of understanding, countless questions still remain, like faint stars hiding behind Saturn's veil of clouds. What exactly lies at Saturn's core? Is it solid, or is it a blurred region of slushy rock and metal? Scientists still debate, and each new model opens yet more possibilities. Those delicate rings, seemingly eternal, are actually raining down into Saturn's atmosphere. How long will the rings endure? 500 million years? 100 million? Less? We still don't know. And Titan and Enceladus? Do their underground oceans and frigid methane lakes hold secrets of life? If life can exist without liquid water on a surface, if life can rely on methane or on hydrothermal chemistry in a deep ocean, then our idea of life must stretch wider, become more open, more diverse. These questions linger like soft, distant lights urging future generations to look upward and wonder. But it isn't only science that draws humanity towards Saturn. The planet holds a special place in our hearts and imaginations. Nowhere else in the solar system is there a world with such supernatural beauty. Those perfect rings, shimmering as lightly as moonlight on a quiet lake, astonish anyone who sees them through a telescope for the first time. Saturn is a painting both gentle and powerful, where science touches art and numbers blend into emotion. Perhaps that is why, across thousands of years, from ancient civilizations to modern stargazing children, Saturn has always been a planet that invites quiet, breathless awe. And when this long story of Saturn reaches its final lines, a slow, lingering image appears. The giant planet still drifting along its wide orbit, turning softly around the sun. Its delicate rings continue to glow like silver ribbons suspended in darkness. Around it, hundreds of moons, each carrying its own story, circle in an ancient dance that never ends. Even as the listener drifts toward sleep, Saturn remains out there, continuing its eternal journey. In the stillness of space, the planet feels like a quiet companion, keeping watch over the night sky, offering you a small corner of peace within the vastness. So allow your mind to rest and slip gently into dreams. Out there, Saturn keeps turning, its rings whispering their soft, endless light, like a lullaby from the universe, tender and unending.